Hello and welcome to another video, this time on quadratic modelling again, but I've just called it rugby and quadratics because I think a rugby ball is being kicked. This is the horizontal distance x meters, so that's distance basically it's flying, and height is h meters above the ground. So this is literally the trajectory, it's going wee like that. Okay, now they're really common, these questions, and I want you to know exactly how to do it because the textbook is rubbish for this, or at least the textbook we use is rubbish for this topic. It really is. They just don't have many quadratic modelling questions, not like this. I mean, they're not that bad once you realise how to do them. Then the ball reaches a maximum height of 12 metres, so I guess that's 12, yeah? And hits the ground at a point 40 metres from where it's kicked, so that's 40. Now, just because of the nature of quadratics, they're always symmetrical. You know that occurs at 20. But we've now got enough to actually write it down. Now, people do this in different ways, yeah? We want to write h as a quadratic in x. You could use completed square form here, yeah? And say, well, you know, as the maximum's occurring at x equals 20, and then that gives you 12, it's going to be x minus 20 squared plus 12. So you might do something like that. But if you look carefully, you'd actually be wrong if you did that, because when x is 0, y is not coming out as 0 as well, and it should be. Yeah, can you see that? Also, there's something massively wrong with this, because it's an upside down quadratic as well. So maybe you think it's 20 minus x or something like that. Yeah, you might use completed square form to do that. Be careful, because you do need an a here, which you've got to find the value of. Yeah. Now at least 2012 makes sense, because when x is 20, y is going to be 12. But does x equals 0, y equals 0 make sense? No, it doesn't, because you're going to have 400a. But this gives you another way of finding it. You can just write 0 equals a times by, 20 minus 0, which is 20 squared, plus 12. And so that's going to be 400a plus 12 equals 0. So in other words, a is going to be minus 12 over 400. Yeah. So that's one way of getting the correct answer. That minus 12 over 100 is like minus 3 over 100, or minus 0.03. 20 minus x squared plus 12. Now, one way to check that we've got it right is by plugging in x is 40 and seeing if we get h is 0. Well, if you plug in x is 40, you're going to get 20 minus 40, which is minus 20. Minus 20 squared is 400. Minus, well, basically 3% of 400 is minus 12, plus 12 is going to be equal to 0. So when you plug in x equals 40, you do get h equals 0. That's how I can see that my answer's right. There is another way of doing this, by the way. You could have done it like this. You might have thought, maybe it's of the form h equals x times by 40 minus x, because that would guarantee that it goes through 0 and 40. But now you've just got to make sure, just making that a bit neater. Unfortunately, that's not quite right, because it won't go through 2012. And so you need a stretching function here again. You need a. And so to find a, just plug in h is 12 when x is 20. I'm just showing you two ways of doing this. Times 20 multiplied by 20. So a is 400 over, 12 over 400. This has a slightly different value for a. It's not negative just because I've already got a negative sign in there. So another possible answer, and it's definitely correct, is 3 over 100. It's definitely equivalent to that answer. It's exactly the same answer. If you multiply both out, you'll see. So 3x over 100 multiplied by 40 minus x. That works, yeah. That's also a quadratic function. So you can use either of those. They're both fine. Hope that makes sense. So the long and the short of it is, if you're ever modeling a quadratic, sure, you can think of it like this. This is the general equation of a quadratic. But more often than not on these ones, they give you completed square form. So it's good to know that completed square form is just x minus a squared plus b. Oh, but put a leading constant a in there just in case you need to stretch it. That's all you need to do. And that will definitely have max value, or sorry, min value, because it's a right way up quadratic, of AB, yeah? And then you can find the value of capital A by plugging another point in there, and then you can deduce the value of capital A. If they've given you the turning point, that might be a really sensible way of doing it. Anyway, part B. The ball passes over a horizontal bar of a set of rugby posts that is perpendicular to the path of the ball. The bar is 3 meters above the ground, so the bar has h equals 3. So maybe we're talking about here and here, yeah? H equals 3. And they want the one which is the greatest horizontal distance, so they're looking for this answer here, yeah? So I'm just going to plug it in. 3 equals, what was my equation? 3x over 100 multiplied by 40 minus x. Yeah, you can use your quadratic solver and your calculator for this. You're going to get minus 3x squared over 100 plus 120x over 100, which is 12 over, well, which is 1 plus 1.2x, if you like. 40 times 3 is 120. 120 divided by 100 is 1.2. And then minus 3. And you can use a quadratic solver to solve this. I haven't got a quadratic solver on me. I haven't even got a calculator on me. That's really bad. But everybody just steals my calculator and stuff at this time of year. My children, my students. So yeah, I'm going to have to let you down here for the answer to that. But if you just plug that into a calculator, the biggest answer should be the one they're looking for, because the biggest answer will be there. The smallest answer will be here. A limitation of the model, well, it's treated the rugby ball as a particle. We need to consider the dimensions of the rugby ball, which means it might fall shorter than that and might not fly over the post, for example. There's one limitation. Has it considered wind or anything like that? It's assumed it's going in a straight line. There are many limitations of a model like that, many which you can give anyway. Okay, so I hope that's been useful, and that was useful for you, Izzy. So all the best and bye-bye.